Dear students, welcome to our science episodes. Today we are going to discuss atomic structure of matter. Atomic structure of matter. Look at this picture. What can you see? A fan? A ceiling fan. Look at the electric fan at rest. Can you distinguish the blades of the fan? Can you count the blades? 1, 2, 3, 4, 5. Easy. Turn it on. Can you distinguish any of the blades? So can you count the blades of a fan while it's working? Of course no. Imagine that the revolving electrons around the nucleus exactly as the rotation of fan blades around the center of the fan. Like this picture, the electrons are revolving around the nucleus at the center of the atom. These orbits are called energy levels. So electrons revolve around the nucleus in energy levels. The energy levels are imaginary orbits. They are not real. And the maximum known number of energy levels in the largest atom is 7. They are represented from inside to outside by alphabets from K to Q. K, L, M, N, O, P, Q. Here are the orbits, or what we call energy levels, from 1 till 7. K, L, M, N, O, P, Q. And this is the nucleus at the center of the atom. Each level has a certain amount of energy that increases by the increase of the distance from the nucleus. This means that the least energy is in level K and the highest energy is in level Q. L level has higher energy than K, and so on. An electron can transfer from one level to a higher one when it gains energy equal to the difference between the energy of the two levels, known as quantum. So when this electron will be excited, this means gains energy, it will jump to a higher energy level. The difference between the energy of both levels is called quantum. Then the atom will be in the excited state. If this electron will lose the energy that it gained, it will return back to its original energy level, which is called the grounded state. So quantum is defined by the amount of energy gained or lost by the electron to transfer it from one energy level to another. What is electronic configuration? Each level from K to Q has a number of electrons which can revolve in. So for example, the first level, which is called K, is saturated with 2 electrons. This means it cannot hold more than 2 electrons. 2 electrons are the maximum number of electrons in the K level. The second level, which is L, is saturated with 8 electrons. So 8 is the maximum number of electrons L level can hold. And so on. The third level, M, is saturated with 18 electrons, and the fourth level, N, is saturated with 32 electrons. Any higher level is saturated with 32 electrons only. So this means that O, P, and Q levels will hold only, each one will hold only 32 electrons, not more. So the rule is the number of electrons represented by the alphabet N equal to 2n power 2. What is N? N is the number of the level order. So this is K is number 1, so N is 1 in case of K. N is 2 in case of L. N will be 3 in case of M, and N will be 4 in case of N, and so on. So the first level, K, where N equal 1, number of electrons will be 2 times 1 to the power 2, which is equal to 2. This rule is to know the maximum numbers of electrons can revolve in a particular energy level. But note that the outer level of any atom is always saturated with 8 electrons. What does this mean? Look to this picture again. M level is saturated with 18 electrons. But if M level is the outermost level in an atom, it will not hold 18. It will hold only 8. Again, N level is saturated with 32 electrons. But what if the N level is the outermost level of an atom? Yes, it will hold only 8 electrons. So again, the outer level of any atom is always saturated with 8 electrons, whatever the level order is, except K level, the first energy level, which cannot be saturated except with 2 electrons. It cannot hold more than 2 electrons. Again, if we have M level and it's the outermost energy level of an atom, it will hold 8 only. Here is L level. L level here is the outermost energy level of the atom. It will hold also 8 electrons only. What about K? No, K cannot hold more than 2 electrons. So now, can you give reason why the equation N equal to N power 2 is not applied for the levels higher than the fourth? Yes, this is because the atom will be unstable if its outermost energy level contains more than 32 electrons. The atomic number of nitrogen atom is 7. So the nucleus contains 7 protons. It has 7 protons in the nucleus and 7 electrons revolving in 2 energy levels. Therefore, the electronic configuration will be 2 electrons in K level. K level can hold up to 2 electrons, not more, and 5 electrons in the L level. The total is 7. The atomic number of sodium atom is 11. It means 11 protons in the nucleus and 11 electrons revolving in 3 energy levels. The electronic configuration is 2 electrons in K level, 8 electrons in L level, 1 electron in M level. So we cannot fill the level with electrons except the one before is completely saturated. Can you predict the electronic configuration of potassium K19 atom? Potassium contains 19 protons in the nucleus and 19 electrons, configured as follows: 2 electrons in the K, 8 electrons in the L, 8 electrons in the M, and only 1 electron in the N energy level. What is the electronic configuration of calcium, chlorine, and neon? Calcium, 20 electrons and protons, 2 in the first level, 8 in the second, 8 in the third, so K, L, M, and then 2 in the outermost energy level. Chlorine with 17 electrons, 2, 8, 7. Neon, 10, 2 and 8. Note that the noble gases always have their outermost energy level saturated with electrons. The electronic configuration and chemical activity. The chemical activity of an element is related to the number of electrons in the outer energy level. What about active atoms? These atoms contain less than 8 electrons in the outer energy level. They can react chemically with another atom or more to produce a stable molecule. What about inactive atoms? These atoms contain 8 electrons in the outer energy level, like atoms of inert noble gas. And this is except helium, which it has only 2 electrons in its outer energy level. So this means less than 8 electrons, active atoms. 8 electrons, inactive atoms, while helium contains 2 atoms in the outer energy level, and it is inactive too. They do not react chemically with other elements. We call them inert. Which elements are active and which are inactive? Helium, aluminum, and oxygen. Helium atomic number is 2. Therefore, it has 2 electrons in one energy level, the K. So this means that the K is saturated. So this gas is inactive. It is inert. Aluminum with 13 electrons, 2 in the first energy level, 8 in the second, and 3 in the last one. Note that 3 electrons are present in the outermost energy level, less than 8. So that is why aluminum is active. Oxygen, 8 electrons, 2 in the first energy level, K, and 6 in the second energy level. Again, 6 electrons, less than 8, so it's active. Time for questions. Can you give reason why K level becomes saturated with electrons before L level? This is because the energy level with less energy becomes saturated with electrons before the higher level. And we said before, or I said before, that electrons cannot go to the higher level or cannot transfer to the higher energy level except after saturating the one before. Write the symbols, atomic number, and electronic configuration of the following. Sodium, 11 electrons, so 2, 8, 1. Chlorine, do you remember the atomic number of chlorine? Yes, it's 17. So 8, 2, 8, 7. So 2, 8, 7. Nitrogen, 7 electrons, 2 in the first level and 5 in the second level. Now choose the right answer. The energy of excited atom is then the energy of an atom in a ground state, more than, lower than, equal to. Of course, it is more than. The following atoms can react chemically without other atoms except we have chlorine, carbon, oxygen, and neon. Except neon. Write the scientific term. The amount of energy gained or lost by the electron to transfer from an energy level to another. Quantum. Negatively charged particles that revolve around the nucleus of an atom. Electrons. Dear students, thank you for watching. See you later in other science episodes.